Hello friends, I welcome you to this channel, Academy of Chemistry Learning. In the series of this stereochemistry, today we will discuss enantiomer and diastereomer. Do you know what is the relation between plane of symmetry and chirality? When any structure or object or any molecule of structure that has no plane of symmetry, and when the molecule has no plane of symmetry, it is called chiral. And as the molecule is chiral, it exists as two isomeric form, and that two isomeric form are mirror images of each other. But when any structure or object which has no plane of symmetry, then it is achiral, and it does not exist as two enantiomeric form. Uh, what is plane of symmetry now? It is important because in the previous lines it says that a structure that has no plane of symmetry or a structure that has plane of symmetry. So we should know that what is plane of symmetry. Any symmetric object which has plane of symmetry means object, if an object is symmetric, then it has a plane of symmetry, or you can say mirror plane. It has mirror plane. And now see this car. In this figure, this car has plane of symmetry, and as it has plane of symmetry, so what happened, its one part is mirror image of another part. So we can say that this car possesses mirror plane symmetry or plane of symmetry. In short, plane of symmetry is nothing but when you divide the object, or when you pass the plane from the center of that object, and both and that plane divide the object in two equal parts, and that both parts are mirror image of each other. That is called plane of symmetry. If an object has a plane of symmetry, then its mirror image will be identical. That means any object or structure possesses plane of symmetry, just like a car. So its mirror image should be identical. We have seen that this car has mirror image, a plane of symmetry, and as it has plane of symmetry, so its mirror image, that is this this is the mirror image of this car, and which is identical, means both are same. Now let's understand same thing when it is applied in any chemical structure. You see this structure, this is the central carbon atom, it has bromine, fluorine and 2 chlorine, and these 2 chlorine atom are one is on wedge side and one is on dash side. This is the side view of this structure. Now when the plane is passed, this is the plane, and when this plane is passed through this uh, structure, so it divides the structure in two identical form. Now let's understand, to better understand, this same structure is shown in different way here. This is the edge view. Here you can see fluorine and bromine in same plane, so they are showing in this vertical position. Now the plane of symmetry is passing from this vertical side, so it divides the molecule in such a way that this one part is identical to this mirror image of its second part. Means this part 1 and part 2 are mirror image of each other. So you can say that this molecule possesses plane of symmetry. Okay. Some more example to understand plane of symmetry. This is the carbon atom. It has two groups which are same, and here blue and gray, two different groups. Now when the observer observes this molecule from this side, so it looks like this. Now when the plane of symmetry pass through this molecule, so what happened? It divides in such a way that one part, this is one part is identical to this or mirror image of this second part. Another example you can see here, this black is central carbon atom, this is the green is one of any group, and these two pinks are another two groups. Now plane of symmetry is passed from this side vertically, so which divide the molecule in two parts, and these two parts 1 and 2 are mirror image of each other. So you can say that this molecule has plane of symmetry. But now in this case you can see this is the central carbon atom, it has green, blue, pink and orange, light orange. So all four groups, all four groups are completely different. So when you pass the plane either vertically or horizontally, they are in cross section. All parts are not mirror image of each other, or you can say all parts after passing the plane, the two parts divides or generates are not identical with each other. So you can say that this molecule does not has plane of symmetry. So this is the difference between this is the two different example. In one example, molecule has plane of symmetry, while in this example, molecule has no plane of symmetry. So I hope that you now understand what is plane of symmetry and how it is occur. Now, next term is superimposable. So when any objects or any structure or any molecule which are indistinguishable from their mirror images, then they are called superimposable. The structures are called superimposable. Now how to understand? Let's see this example. This is the carbon atom. It has two hydrogen atoms, one HOS and Br groups are there. Its mirror image should be like this. Now take this structure and put it on this structure. So what happened? All the groups or all the atoms are fixed or exactly match with this its mirror image structure. Bromine will overlap on bromine, these two hydrogen will overlap on this hydrogen, and OH will overlap on OH. So you can say these two mirror images are exactly match with each other, and hence they are superimposable mirror images of each other. Means both are same, they are indistinguishable. You cannot separate out that which one is actual structure and which one is mirror image. So it is called superimposable. Now what about the non-superimposable? The non-superimposable are the structure or the molecules which can be distinguished, means they are completely different. Let's take the example of our hand. If you see your left hand in mirror, so its image should be look like a right hand. Okay, now take the left hand and put it over its mirror image, that is right hand. So what happened? It looks like this one. So you can say that these two structures or these two objects are left hand and right hand, its mirror image right hand. Both are completely different from each other, or you can say they can be distinguishable. You can separate out that this one is left hand and this one is bottom side is your right hand. So they are non-superimposable, you can say. Means they cannot be exactly matched with each other when you overlap one over other, and so they are chiral objects. One more example of superimposable is you take this conical flask. When you see the conical flask in mirror, so its mirror image is exactly similar to it. Now when you take conical flask and put it over its mirror image, So both will overlap each other exactly that you cannot distinguish them. Means they are indistinguishable. So they are achiral structure. So these are the examples of superimposable and non-superimposable. So for some more example of superimposable and non-superimposable are a pair of hand gloves are non-superimposable and hence they are chiral. A pair of our foot, they are also non-superimposable and hence they are chiral. A pair of socks. Now in case of socks, what happens when you put one over another, that is its mirror image. So what happens when you put take this one and put it over its mirror image, because this is mirror image of this previous one. So both are superimposable and hence they are superimposable, they are achiral. So this is how you can find out which one is superimposable, which one is super non-imposable, and from that you can decide that the object or structure or molecule is chiral or achiral. And once you know that molecule is chiral or achiral, you can find out its whether they are enantiomer or diastereomer. So the chiral objects which are non-superimposable mirror images of each other, our hand and footprints, while this glass ball, these baseball sticks are non-chiral objects and they are superimposable mirror images of each other. So from all this we can conclude that a structure which is achiral are superimposable on their mirror images. Means they fit or they exactly match with each other because they possess plane of symmetry. And chiral structures are non-superimposable, and as they are non-superimposable on their mirror image, they have no plane of symmetry. Now, what is meant by enantiomer? Any optical isomers which are non-superimposable mirror images of each other are called enantiomer. So, if you know what is chiral, if you know plane of symmetry, if you know they are superimposable or non-superimposable, then you can easily find out that isomers are enantiomer or not. So what is the definition of enantiomer? Any optical isomers which are non-superimposable mirror images of each other are called enantiomer. As uh, enantiomer says that they are non-superimposable mirror images, that means they are distinguishable structures or objects. So they are both are different molecule, but their physical means their three-dimensional rearrangement is different. They have physical and chemical properties are same, like the structure, melting point, refractive index, density. But the one thing that differentiate between these two isomers is optical rotation. Both have shows different optical isomers, optical rotation of plane polarized light. One will rotate the plane either in clockwise or, and while the other one will rotate polarized light, plane polarized light in anti-clockwise direction. So enantiomer or enantiomeric isomers has characteristic that they have different optical rotation. So the pairs of enantiomer are same compound with same properties, but they differ only in direction in which they rotate plane polarized light. So remember very well how they can be distinguished by rotation of plane polarized light. Now what is meant by diastereomer, or you can say diastereoisomers? Any optical isomers which are not mirror images of each other are called diastereoisomers. Means diastereoisomers are not mirror images of each other, and as they are not mirror image of each other, so they are completely different structures, different molecule, and hence they have different physical and chemical properties. Diastereomers can be achiral, means they have plane of symmetry, or they may be chiral, means they have no plane of symmetry. So in case of diastereoisomers, there are two possibilities. Either the structure possesses achiral center or chiral center, and these two diastereoisomer pair are different compounds with different name and different properties, while in case of enantiomer have same properties but different in their rotation around plane polarized light. Now see the example of a diastereomer and enantiomer. This is the compound number 1. Now its mirror image, when you see the compound number 1 by putting the mirror, so its mirror image should be like this, that is compound number 2. Now this when you take this compound number 1 and put it over this compound number 2, so what happened? They cannot be superimposable, so it is non-superimposable. And what is the as per the definition of enantiomer, when the mirror images are non-superimposable, so they are enantiomers. So this compound number 1 and 2 are enantiomers, pair of enantiomers. Now take the structure number 3. Its mirror image should be look like compound number 4, and when you put the structure compound number 3 over compound number 4, so they cannot be exactly matched with each other, and hence they are non-superimposable, so they are enantiomers pair. Now what about the diastereomer? So compound number 1 and compound number 3 both are not mirror image of each other, so as per the definition of diastereomer, they are you can say they are diastereomers. Now compound number 1 and 4 are diastereomer because they are not mirror image of each other. Compound number 2 and 3 are also diastereomer, and compound number 2 and 4 are also diastereomers. So this is how you can find out enantiomer and diastereomer. Another example to understand enantiomer and diastereomer is D-erythros. Now when you put mirror and see the structure of this D-erythros, it should be look like L-erythros, like this. Now take the structure of D-erythros and put it over L-erythros. So what happened? They are non-superimposable, and as they are non-superimposable and they are mirror images of each other, so they are called enantiomers. Now same way, if you take the D-trios and see its structure in a mirror, so its mirror image should be look like L-trios. Now when you put D-trios over L-trios, so they are also non-superimposable, and as they are mirror images, so they are also enantiomers. Now this D-trios and D-erythros, D-trios and D-erythros are not mirror images of each other, so they are called diastereomers. Same way, L-erythros and L-trios are not mirror images of each other, and they are completely different structures, so they are diastereomers of each other. So this is all about plane of symmetry. Then from plane of symmetry you can find out chirality and achirality, and from that you can find out whether the molecule is enantiomer or diastereomer. So I hope you understand it very much. Thank you.